If your science teacher said light always bends the same way, they missed a memo. You see, for centuries, the fundamental principles of optics have been taught in classrooms around the world. From the way light refracts through a prism to how lenses and eyeglasses correct our vision, these principles have been the bedrock of our understanding of light. But what if I told you that a tiny object has just turned these age-old principles on their head? Yes, you heard that right. This minuscule structure has not only challenged our understanding of physics, but has also opened up a world of possibilities in the field of optics. If your glasses help you see clearly, thank boring old physics. The lenses in your glasses work by bending light in a predictable way, correcting your vision so you can see the world clearly. This bending of light, known as refraction, is a principle that has been well understood for centuries. But what if we could bend light in ways that were previously thought impossible? Imagine glasses that could not only correct your vision, but also enhance it in ways we can't even fathom yet. This is the kind of revolutionary change we're talking about, but if your nanostructure bends light backwards, congratulations, you're a rebel genius. This is exactly what a group of pioneering scientists has achieved. By manipulating materials at the nanoscale, they have created structures that bend light in the opposite direction to what we would normally expect. This phenomenon, known as negative refraction, is not just a quirky trick of physics, it has the potential to revolutionize the way we design optical devices. For centuries, we all agreed light bends when it passes between stuff, like water, glass, or air. That's called refraction. This basic principle explains why a straw looks bent when you see it in a glass of water. The light changes speed as it moves from one medium to another, causing it to change direction. This bending of light is something we encounter in our everyday lives, from the way we see objects underwater to the way lenses focus light in cameras and telescopes. It's why a straw looks wonky in your soda. This simple demonstration of refraction is something we've all seen, but it serves as a perfect example of how light behaves under normal circumstances. Now, imagine if we could control this bending of light in ways that defy our current understanding. The implications are staggering, but some scientists just changed the game. They have developed a new class of materials known as metamaterials. These materials are engineered to have properties that are not found in nature. By designing these materials at the nanoscale, scientists can control the way light interacts with them in unprecedented ways. They built a metamaterial, basically a nano-sized Lego fortress for photons. These metamaterials are constructed with intricate patterns that are smaller than the wavelength of light itself. This allows them to manipulate light in ways that were previously thought impossible. Imagine a fortress made of Lego bricks, but on a scale so small that it can interact with individual photons of light. The twist? When light hits it, it bends the wrong way. This is the phenomenon of negative refraction. Instead of bending in the direction we would expect, the light bends in the opposite direction. This counterintuitive behavior opens up a whole new realm of possibilities for optical technologies. It's called negative refraction. And yeah, that sounds illegal. But it's not just a theoretical curiosity. Negative refraction has practical applications that could transform various fields, from imaging and microscopy to telecommunications and even cloaking technologies. So, how'd they do it? The process involves advanced techniques and cutting-edge technology. One of the key methods used is electron beam lithography, a technique that allows scientists to etch incredibly fine patterns onto materials. Using electron beam lithography, they etched patterns smaller than a virus onto special materials. These patterns are so small that they can interact with light in ways that bulk materials cannot. By carefully designing these patterns, scientists can create metamaterials with the desired optical properties. The result light didn't just follow the rules, it moonwalked right past them. Why does this matter? The ability to control light in such precise ways has far-reaching implications. For example, it could lead to the development of super lenses that can see details smaller than the wavelength of light, breaking the diffraction limit that has constrained optical microscopy for so long. Think next-level microscopes, ultra-fast data, and, you guessed it, actual invisibility cloaks. These are not just science fiction fantasies. The principles of negative refraction and metamaterials could make these technologies a reality. Imagine microscopes that can see inside cells with unprecedented clarity, or data transmission systems that are faster and more efficient than anything we have today. This tiny structure could change how we see, communicate, and even hide. The potential applications are vast and varied. From improving medical imaging to creating more secure communication networks, the impact of this breakthrough could be felt across multiple industries. So, what would you do if you could bend light however you wanted? The possibilities are limited only by our imagination. Whether it's creating new types of optical devices, enhancing our ability to see the microscopic world, or even developing new forms of entertainment and art, the ability to control light in such precise ways opens up a world of opportunities. Hit like, subscribe for more science magic, and tell us your wildest idea in the comments. We are living in an exciting time where the boundaries of what we thought was possible are being pushed every day. Stay tuned for more incredible discoveries and innovations that will continue to change our world.